Welcome to a new test and teardown video. Here is another Marconi FM signal generator. This model is called TF1066B/1. I know how old this one is, because look what I found. In the handle side in here. This sheet was hidden. So this is the correction percent factor at frequency chart something. And look, it says 1958. So I mean, this model is designed in 1958, right? And this is actually older compared to what I can find online. Most of these are from 1960 or from 1962, the two other models. And if you look at the different pictures, it's real easy to see where is the on indicator. Is it here? Is it here? Or is it up in the left corner? So that's the three different models. This is how they look like. So I bet this is the earliest version, where it's down here a little bit to the right of the middle. So the 5 ranges, the 5 bands, they go from 10 to 470 megahertz. And look at this one. Rotate 1 and 1/5. Look at that. So if I want to go from C to D, look at this. And then click. I mean, and it goes real nice and smooth. And then you can just keep turning this all the way around. You can feel there is something real big and heavy behind this, but it's geared in a really nice way. Other generators don't have this gearing, and you really need to like punk, and you need to really use a lot of force, and it feels like you're breaking the button or the knob every time you change the bands. But this one feels like a super good design. So I really like this geared approach. And this is of course the fine tuning. And if we look at the 5 bands, you'll see the resolution is very different, obviously. So see here, this big distance between 16 and 17 megahertz. And here again, then it's 2 megahertz, and here it's like 5 megahertz, and so on and so on. So of course it's not the same kind of resolution when you are in a very high frequency band. But anyway, I look forward to see how accurate I can trim this and how stable it will be directly from cold. I think I'm gonna go to the 2 meter radio band and dial this into in the middle of the 2 meter band. So it's gonna be around here, right? There's also an electrical fine-tuning of the frequency and the typical set carrier. So you set the drive to the power stage, and in that stage you'll know everything is running correctly. We got different modulations, FM and AM, internal FM or internal AM, or of course external. And I bet this is carrier off, and then it's just a constant wave. The frequency modulation or incremental frequency is done using this knob. See, modulation, and then how much or incremental frequency is again in those ranges, or it's in the shadow, I'm sorry about that. And then you got variable or in steps, and all the different steps as shown up here. And then we got fuses, modulation input. Yeah, there's not a lot to say about this. I don't know if this works or if it takes the fuses, so I will try and power it up. But look at this thin, flimsy mains cord. I mean, this thing is full of tubes. I don't know, is it 8 tubes or something like that? And then this thin. All right, let's try. So this is going to be the first power on experiment. And that was mains. Nothing bad happened. And I got grounding here, earth protection. So let's see if there's any light left. 90 watts, 70, 60. It goes a little bit up and down here. That's 50. Okay, so it's stable about 50, 60 and 70. And we got life. Look at that. That is a good sign. Set carrier. Yes, that is exactly what I wanted to see. Just that I'm using a range, and let's see the attenuator. Oh, I think we got output. Oops. That is output. So what is that? 14.4 megahertz, and let's try and dial this in here. Let's try and set this as accurate as we can and set the fine tuning in the middle. There isn't any other funny stuff to poke around with, right? And then it is 14.94. And it's just powered on, right? So that seems to be running quite smooth. So that is good. So that was in CV, and that is definitely carrier off. Internal FM. Internal AM. Let's see if there's anything happening here. Oh, modulation is here, right? What are we doing here? This is of course my fault. We should go all the way down to millisecond. Let's crank up modulation. Nope. Yes, this is internal. See, the modulation oscillator is not running. Or is it? I see a tiny little bit. That is boring. But I see some funny meter reactions. It's probably just bad connections, because look, sometimes I see something going on here. But there is a little bit of... Anyway, I think it's time to power this off, and let's look inside. Before I go inside, I was just thinking a little bit more about testing all the different ranges and testing a little bit more of the features. So now I am in range E, and let's try and dial this for 320. I mean, it's very, very close. How about we see if it can do the maximum of 470? if I dial it all the way. So that is 60. So it's like that, right? Yes, it can, definitely. Let's see if we can continue a little bit. Okay, 500. If I go all the way, let's just continue until, oops, 526. I just continue all the way to the scale maxes. So that is 526 is what this thing can do. Oh, wow. See, this was the test I was talking about earlier. I adjusted it 445 and I hear the squelch is open. See if I play with the fine tuning. Can you hear it? So if I stay in the center of the channel, it's really quiet and stable. That is amazing. I am now in internal FM and I've been poking around with the band switch and now I got modulation. So that is 1 kilohertz. Let's go 5. And of course this radio is not designed for this. But so we got FM modulation. Yay! Oh, I've been playing around with this for a little while now. And the conclusion is all the FM is working, AM is not working. We know the oscillator is working. You can do the different frequency. See, I'm now in internal AM and there's absolutely no response whatsoever on the meter and on the output. So that is what we need to look for. That should be fairly easy. Now it's time to open. Let's look inside this wonderful unit. That'll be the mains transformer. Really big. And all the different frequency steps and frequency modulation and all that goodies. That is the, here we go. That is the attenuator. I think it is easier to see from the bottom. See this little detail here about it goes outside of the box. So there is a little, hang on, I'm gonna show you this. This is the side of the box. And there's this little hole outside of the box for the attenuator. I mean, this is kinda, oops. We placed the attenuator a little bit stupid place and oh, we want so much attenuation and yada yada. Oh, why not build a little thingy so it can, I don't know. I am not super impressed about that solution. I would probably have sacrificed a few dB attenuation or something like that. Everything is really tough and stable and big and strong and all that stuff as always. I mean, look at the size of everything. This brass fitting is like massive. I think it's 15 millimeters, that one, really big. I took off the shielded top case here because I wanted to look at the band switch. So this is the case. Oh, it was, yeah, here it was. See, I always add those little tiny marks so I can assemble stuff the right way again. The way that this is closed is actually pretty genius. So it's really fast just to loosen the screws, pull out this piece, yeah, all the way around, of course, and then you can easily open the unit. I mean, that is super service friendly, fast and easy. I flipped the unit so it's a little bit easier to see what we're doing here. And this is the band switch. I want you to see the really cool details about the oscillator tube and all the different bands. The coupling in and out of the oscillator is not done by switches, but it's done by this piece here. We got two of them in and out of the resonant circuit, and it's done by capacitance. So that means there are no contacts that can go bad or good. It will just always be good, right? Always be the same and always be perfect. I mean, that is just so genius, as you can probably imagine. So this is the band switch in position, and the next one, and so on. And this is the modulation coils. And the modulation coils, they go to contacts, to mechanical contacts, as you can see here. Click. And the modulation coil actually is magnetically coupled. I don't know if I can show you this. It's coupled to this coil up here. Oh, let me just find something to point with. Here, this part up there. Let me see if I can show you this. So this is the fastest frequency mode, obviously, because we got only one winding here. I mean, it's just absolutely amazing the way that the current in the modulation coil affects the oscillator coil, so that it changes its frequency, because this unit was designed before the varactor coil diode was invented. So they needed to figure out how to do FM modulation. See, that was the fastest, and that is the next one, the next bands. That is real genius. So let's just put this in between two bands. I want to show you this capacitor down here. So this is the variable. So now I'm changing the frequency variable, and that is done on the inner side of each band. So there's another capacitor in here, right? Isn't it just amazing? Let me show you. Yeah, I think it's just this same. I really think this is super cute, the way that this is made. I haven't tried to pull up the oscillator tube, but as long as everything here is perfectly in alignment and everything works really good, there is no reason for me to poke up the tubes and mess around with stuff that is perfectly in calibration. That will be feed through. And here we got also feed through for all the different AM and FM and filament and anode supply. And down here we got the other tube that is also inside the box, inside the super shielded. What else can I show you about this unit? Yeah, we know that AM modulation is not working, but FM is working. If we look at the schematic, so let's look a little bit at the schematics, shall we? Then we'll come to V4. Let me show you the schematic. This is a pretty good quality schematic, but this is unfortunately the newer model compared to the unit I got. But since this is a much better quality, I would like to show you a few of the details that I just shown. The oscillator part here, as you can see, some of it is the oscillator. This is the oscillator tube that I'm pointing at here, and this is connected to the selected oscillator coil. But then there is another coil that couples to that coil that is also switched in, and this is the modulation coil. As you can see here, it goes to this this transformer, and this is the FM modulation tube. Okay, so we don't have AM, so that is this tube, right? This is in this unit, it's called V7, but in my schematic it's called V4. Let's show you the difference between this is the this new V6 or -6 version, where they use rectifier bridges, they use a little bit different power supply, a little bit more diodes, stuff like that has been changed a little bit. So let's see if we can show you guys the version that I got. Where is the... Here we go. This is V6. No, V4. So this is the AM modulation tube. And if we look at V4 here, the funny thing is external modulation is both an input on output. This is actually a little bit funny, right? So this is carrier off position, and in carrier off, as you can see here, I get 0 voltage on this point, and this go on, or this becomes the anode voltage for the output tube. So no anode voltage, you get no carrier. So in the next position, we're probably going to have a CV, because see, we got no modulation, so this is constant wave. Then we got FM. See, FM is here. And this just gives a nice DC voltage. This voltage just goes straight to the tube, to the anode side of it, okay? So here is AM internal number 4. So the voltage on the top of V4 is now connected to the output tube. Okay, so what we want is, we want AC here. This will generate AM modulation. And this is what we do not have. We know the oscillator is working, we know FM is working, all that stuff is working. So that means we're absolutely sure if the switches and all that stuff is working, you know, we should have voltage in here. And I've already checked, we don't have, or we have indeed voltage in here, but we don't have anything out here. So what we're going to go and check now is this tube working or not? So the easiest way to see if something is good with a tube like this, we've just seen the schematic, so there's no need to repeat everything once again. But here's the capacitor that is connected to ground, and look, this yellow wire goes to the cathode, 1K to ground. So that is super easy to navigate around here and see this. And what we got is 0 volts. And we got filament, as you can see. So the next thing we need to measure is if we got anode voltage. So hang on. And it is that simple. We got plenty of anode voltage, and this is the 100 ohm resistor to the first grid. This will turn on this tube's current fully, and you see exactly the same voltage as the anode voltage. So there's a fully turned on tube, and there is just 0 current going in the tube. So how is that possible? Okay, let's look at the signal grid. There's a 1 mega ohm resistor to the input, and let's look at that. Also 0 volts on that input. So there's only one thing to say about that, and that is this tube is not working in any way at all. Yeah, here is the 6L6G, or normally just called the 6L6. And this one is the one that is not working. Ooh, still nice and warm. And all I have to do is just go and look in my little box of goodies and oldies, and then I find this. And I don't know if this is easy to see, but this is a 6L6GB. How about we just plug this in, huh? So, the new tube is in, and all we have to do is crank up. Did we turn it on? Yes, we did. There's nothing so far, but of course, yeah. Sure, this is a little bit high. Is it really that high? Well, that's just how it is. So 21 milliamps of cathode current is what we measure here. So all we have to do now is go and check if we got AM modulation back. So we connected the output, and I think I got it into AM internal, right? So this will be, yeah, look at that. What have we got? Ha ha! All I have to do is grab this one and look over here. And AM, yay. Solve the problem. Putting in a new lamp. It is that easy, isn't it? So let's turn this off and have a nice little look at this beautiful unit. It's actually full of also transistors. I think it's like 3 or 4 transistors in this unit. We got a few diodes as well. So it's not an old tube device. I think that will be the rectifiers. Probably selenium or some nasty stuff like that, right? Ooh, that one is bad. I have to clean that up. But there is a good contact anyway, but I prefer to leave stuff much more nice and clean. And that would be the different adjustments for the different ranges. It's really nicely placed here, and you can access this through a little door in the back of the cabinet. So that is so we are able to calibrate everything later. Got quite a lot of fuses. They're easy to access. This looks a little bit like somebody replaced a capacitor here, right? I mean, this can't be original. This is also a new soldering and some stuff here. Yeah. Let's flip it around and show you guys the voltage, high voltage regulator, because that is the big boy here. this is also a modification that is not in the schematic. So somebody replaced the rectifier tube with 2 diodes and 2 resistors. That is actually a really good way to do it. It's a little bit weird they used 2 resistors because the power comes from either that one or that one, and then it goes via 2 resistors. That's a little bit stupid. Maybe they just needed more power capability, but in reality you could have used only one, because it's good to simulate the tube's characteristics with series resistors, because that's more like how a tube would do it. So I flipped the unit. It's actually powered on, just to see if I can show you guys the big, beautiful voltage regulator tube. So this is the pentode, that is the feedbacked voltage, high voltage supply, and this will be a voltage regulator tube. And down here is the, I think you can't really see it from my finger, that one down there is the feedback system to the power pentode. Let's turn off the light here and see if we can probably get... Nah. Yeah, we can see the voltage regulator tube is shiny. They painted it black. That is a shame, because I really like the way they glow. So beautiful. We're not supposed to see that. Hey, too bad. I mean, look at the thickness of materials. That's really, really genius to make triangles. So that means this is super stable sideways. That is smart. The whole oscillator unit is really, really thick and massively heavy. I don't know if you can see. This is of course not so much material, but everything is just that thick. And I don't know if I already mentioned this, but this unit is 27 kilos. 27. So it's very, very hard to handle for me here on the table, actually. Whew, yeah, it's tough. Look at all the... I mean, is it really needed with that much, that thick? It's just everywhere. Made as thick and solid as possible. But that is just how it was back in the good old times. You know, maybe you get what you pay for, or quality was measured in on a weight scale. I don't know. I think it's time to say goodbye for tonight. I will just clean up the last little fuse detail here and remove all the dust and stuff. See if I can make it nice and shiny, and then I will assemble my nice, good working generator again. I'm super happy about that.